Hi guys, today I'm going to show how to implement ship buoyancy in Unity. First of all, let's create a new project in the universal pipe renderer and let's call this name. Let's give it name as Vatosimo. Now let's delete the sample assets from it and also the simple camera controller script from it also. Now let's create a new scene called water simulation and we can delete the rest of the scenes from it. Now add a plane into it and also remember to remove the mesh collider from it. Now let's name this plane as water. Now we can also create a material for this plane. I think this color will be enough for it. Now create a cube. Let's name this cube as boat. And also add a rigid body component to it. And apply a small drag into for the cube. Now let's create a script called floater. Open the script. We need to reference to the rigid body and also for two floats. In the fix the update method, check if the y is less than 0, in which case we consider it as underwater, meaning we need to apply buoyant force to the cube. If the statement we calculate displacement multiplier by taking the y position and divided it by the submerged value and clamping that between 0 and 1. It affects how strong our buoyancy force will be, and we also multiply the whole with the displacement amount. Then add a upward force to the rigid body with y component equal to the force of gravity multiplied by the displacement multiplier. We also use a acceleration force mode for it, so that the buoyancy is not affected by the mass. Let's save this script and attach this script to our boat. Now let's hit play. Now as you can see, our cube is floating in our water plane. You can play with track if you want. Now let's create a new script called Wave Manager. Let's open the script. Inside we create a basic singleton. If you don't know what that is, it will allow you to access a specific instance class anywhere in the project. We're also ensuring that only one instance is in existence. As you can see, the instance equals to this. Else if instance not equal to this, and let's write debug.log equal to instance already exists, destroy this, destroying the object. Now we are going to use a basic sine wave function to simulate the water wave. So we need a field for amplitude, wavelength, speed, and offset. In an update method, we will increment the offset by speed multiplied by the time delta time. We also create a method which will return the wave height at the given x-coordinate. Inside we take the x-coordinate divided by the length of the offset and pass it to the sine function. Then we will return the result multiplied by the amplitude. Now we will easily grab the wave height of the given point in the world. Now we need to incorporate it in our buoyancy code. In the floater class fixed update method, get the wave height at the floater x position. Instead of checking the floaters y less than 0, we will now trace it as less than wave height. Also in our displacement multiplier calculation, we need to subtract the y position from the wave height before dividing by the depth of submerged. Now let's fix the error from this. I forgot to write a float in this. Now let's attach the wave manager into our water plane. Now let's hit play. Now you can see now our cube is floating as it is in a wave. You can also play with the amplitude, wave height and speed and offset if you want to change that things. Now let's create a new script called water manager. Let's open the script. Let's attach the script in our water plane. Anything that we attach, this should also have a mesh filter and a mesh renderer component. So we have informed that with a require component attribute. Add a field to store the reference to the mesh filter and assign it in the wave awake method. Now in the update method, we also grab the mesh vertices that we need to loop through the array and modify the Y component based on the global X component. Finally, we assign the vertices to the mesh and call it in the recalculate normal method to make sure the mesh normals are correct. Let's hit play. Now you can see our cube is floating on a wave. I hope you all enjoyed this video. Thank you for watching. Thank you.